Page 139, we're looking at lesson 3-5, so let's go ahead and get started. 3-5, perimeter and area. Perimeter and area. I hope no one's talking without permission because they stayed during break. Okay, this is geometry. So when we're talking about perimeter and area today, thankfully, we're talking about rectangles. Can somebody define for me what a rectangle is? Geometry. Don't show me or tell me something that you think might be. Give me a good definition. Michael.
A long square.
A long square. Okay. Actually, that would be something we kind of understand, but I need more to it because it's not exactly a good definition per se. Mackenzie?
It's a 1D quadrilateral with uneven sides.
Okay, it is a quadrilateral. I'm going to take that. Quadrilateral. What's a quadrilateral? It has how many sides?
4.
4 sides. So it's a polygon with 4 sides. So far, so good. Give me more.
It's a parallelogram.
It is a parallelogram.
Opposite sides parallel and equal.
Opposite sides are parallel to one another and they are congruent. That's good. Good. That's geometry right there.
It has like 2 lines that are long and 2 lines that are short.
Okay, he's saying 2 lines that are long, 2 lines that are short. How about this, guys? It's a quadrilateral. It's a parallelogram. There's a little bit more to it, but draw me the most unique rectangle. Not too big. Just draw me a rectangle somewhere on your paper that's as unique as anyone else in this class, or more unique than what this class can do. So I'm guessing this is not going to be the most unique. Oh, yeah, look at that. Okay, that's the most typical example of a rectangle, but there are other examples.
Oh, question. Isn't a rectangle a square, or is that just a square rectangle? No, a square.
Great question. I'm going to let you draw and then I'll answer it because you're actually getting to something. So just keep going. Keep going. I'm not going to answer that outright. You actually brought up a good point, which I will further. Oh, look at those unique rectangles.
They have to be even.
Darn it, I'm just drawing a rectangle. I don't know how to draw a rectangle. That's a trapezoid.
They need to be next to each other.
Are we acting like the lines are unique? I mean,
Even?
even.
Yeah, and mine aren't perfect, but you just get a sketch going. Okay, listen carefully. I'm going to see about the uniqueness in just a moment, but first of all, I want to know this. Okay, whatever rectangle you drew, and it doesn't have to be perfect. Mine is not perfect. I can even see, oh man, that's slanted. But you're sketching. All right, this is what needs to be true. It needs to be a 4-sided figure. So check. You have, so far, you have part of a rectangle. All right, second thing is you need to have all right angles. 4 right angles. If you have 4 right angles, check number 2, you're good. All right, opposite sides, such as these two, which are opposite sides, or those two. Both pairs of opposite sides need to be parallel, or at least close to parallel. Again, here, not super parallel, but I can get the idea. So that's check number 3. 2 sets of parallel sides. Okay, the most unique rectangle. So please don't show me this one. That's not unique. Most of you did that. Okay. How about this? Can you show it to me? Real quick.
Okay, so this is here.
No. Okay. Next. Oh, all right. Michael, he gave me a good one here. And I didn't give it exactly, but he gave me something like that. That's not bad. A long rectangle. Show it. Show it up, please.
I put the markings.
Okay, he put the markings and he did this. I'm going to draw this reason, John. He kind of got it at a slant, which is still a rectangle. All right, let's go to another one. Here.
You could have like the angled one.
That isn't.
All right, how about this? Let me help you out, girls. Oh, wow. Let me do a little pause here. The reason I let you sit wherever you want, it's a very simple reason. For one day I do that because I'm like, yep, they can sit together. They don't distract each other very much. These people cannot sit together. Not going to happen. It's easy. It makes my seating chart very easy. So some of you are like, yeah, you're proving to me, yes, you can sit next to somebody next to you. And some of you are proving, I can't. Just can't do it. So you're helping me out and you're helping yourself out. Okay. Any other unique rectangles to this to these three. Just show it to me when I call on you.
This thing.
That is a parallelogram, but it's not a rectangle because it doesn't have 4 right angles. Yes, Emma Grace. That's kind of the same thing. Those angles are not right angles. They look like. I think you should do this here. That's a parallelogram, but none of these angles are right angles.
So it can't be a rhombus?
No, I'm not going to say it can't be a rhombus. It can, but it has to have 4 right angles. Yes. I need to see it closer. One more after this. Yeah, go ahead. Oh my. Okay. Yes, it has to. JB, last one here. Oh, he has many rectangles. All right. Another rectangle, guys, you could have done was this. All right. Bella. Self-control. Okay. Here. Yes, that is a square. A square is a rectangle. So let me ask you this. Is it 4-sided? Does it have 4 right angles?
Yes.
Does it have 2 sets of parallel sides?
Yes.
It is a rectangle. So rectangles can look like any one of these as long as it has those 3 criteria met. So if you have that, you're good. Okay, look on page 139. Let's see what we're actually going to do with it. Okay, today we're talking about those rectangles and we're dealing with area and perimeter or perimeter area. And if you're looking at the bottom of page 139, do you guys see where it says perimeter of rectangle, of a rectangle? Can someone read that little greenish, brownish, tannish box? It's hard to describe that color. Okay, Sophie, go ahead. In words.
If a rectangle has a length of, is that
An E.
units?
Oh, L units.
L units and a width of W units, then the perimeter is twice the sum of the length and width.
All right, thank you very much. And can you try it with the symbols?
T equals 2, parentheses L plus W.
Okay, perimeter of a rectangle, we're going to look at one formula, and we're going to describe what those parts mean. The first one for perimeter is P. What do you think P stands for, by the way? Perimeter. It just stands for perimeter. Equals 2 times the length plus the width. 2 times the length plus the width. And yes, that is a strange L, but why do you think they have to make it a cursive L? Not just like, my L's are just like right here. What do you think? Yes, Elizabeth?
It looks like a 1.
Yeah, L, a lowercase L, can look like a 1. So we don't want to confuse that. We'll do you can do a cursive L. Why wouldn't it be a uppercase L? Why can't you just do that uppercase L? Okay, yep, Tristan?
It's like a right angle.
Okay, it might look like a right angle. There are reasons why we use different letters. Uppercase letters are dealing with the formula, what you're trying to find in a formula. So what are you looking for? Perimeter? Capital P, not lowercase p, capital P. So all the other letters have to be lowercase to describe the capital, in this case, perimeter. Okay, how in the world did we get P equals 2 times L plus W? Where did we get that from? I just made it up. The book just told me. How in the world does that come up?
Do we know what P stands for?
Yes, we should. What does it stand for? Perimeter. So perimeter. But John, how do we come up with 2 times L plus W?
Can't you give us like a sheet? Like if you're trying to find what size is, like what's each side, how long it is, then they'll put like L can be on one side and then they'll have like 2 and 2. So what is L?
Okay, so good. You're thinking about it like a type of problem. All right, your rectangle, whichever rectangle it was, I'm going to use this one up here. I want you to label the length and the width. Okay, go ahead and label it.
Oh, I know.
On your rectangle, you have a different one I have. So here, I'm going to do this. That's my length, and I'll call that my width. So you do it. You may start thinking of a question, Mr. A, how do you know which one's the length and how do you know which one's the width? There is no, I think what you're going to say is, there is no like exact way of doing it. In fact, you know what I could have done here? Could have switched them around. But what do we normally think of length and width? What's the difference between length and width?
Length is the really long one.
Length is typically the longer one. Width is the shorter one. That's a good way to think of it. Just think of it that way. Could it be switched, though?
Yes.
Okay, so don't be afraid if they do this. The width is 10 and the length is 5. You're like, wait, that can't be. No, it can be, and that's okay. But we typically think longer side is length, shorter side is width. Okay, what is perimeter, though? What is perimeter? So, like, we get how to figure out perimeter, but what is perimeter? We need to get this. This is a definition. Okay, Braden?
All the sides put together.
Okay, give me a little bit more to that. I get what you're saying, but like, how do you say it mathematically? All the sides put together, but added together. Okay, this is what we're going to define it as, and that's a working definition. So perimeter of a rectangle is the distance around a rectangle. Oops. The distance around a rectangle. Yes, ma'am.
Couldn't you use perimeter for like a circle?
Yeah. So what do we call the perimeter of a circle? There's a special name. So it's a special name, circumference.
What about an octagon? Is there like...
So you would just replace it with, so to find the perimeter of a rectangle, you find the distance around a rectangle. To find the perimeter of a, let's just say, octagon, you would find the distance around an octagon. So we're just dealing with rectangle, but yes, you could find it of any polygon. In fact, you can find it of any shape out there in the world. Any shape around here, you can find it. Now, look at your desks. What shape does it most relate to? Most. I'm not saying it is, but which one does it most relate to? Tristan?
Square?
Rectangle. I'm going to say it's a rectangle. Well, why would I not say it's exactly a rectangle? What's wrong with it that's not exactly a rectangle? Because rectangle, it's pretty rectangular. There's just something a little bit off about your tables. Manufacturer defect. Marissa? Yeah, do you see these little edges, guys? As much as it looks like they're not right angles, okay? They're actually curved. And these are not polygons, but is it pretty useful to know that this is close to a rectangle? And therefore you could find the distance around that rectangle? Yeah, but it's not a perfect rectangle.
Would this, then what
Yes, ma'am.
type of angle would that be? A curved angle?
Well, see, and that's the thing. It's not an angle. It's not any angle because it's a curve. So we got to look at it now as like a semicircle, part of a circle. Yeah. Which, yeah, like a circle is a giant 360-degree angle. Okay. Let's look at example number 1 and see how we actually use it. Example number 1. And we're looking at A. Find the perimeter of each rectangle. When it says to find the perimeter of a rectangle, what are they asking for? Find the distance around that rectangle. That's all they're asking for, the distance around the rectangle. So that diagram, excuse me, I'm just sketching it out. It doesn't have to be perfect, but 4 inches and 9 inches. So 4 and 9, and they're inches. Okay, so all you have to do, one way to do this, is you start at one point and you just work your way around. So you go here, 4, 9. What would this be? 4, 9. So I'm going to mark that just to make sure we all know what I just did there. So you can do 4 plus 9 plus 4 plus 9. 4 plus 9 plus 4 plus 9. But there's an easier way to work it out. So instead of adding 4 plus 9 plus 4 plus 9, you use that formula. P equals 2 times L plus W. Okay, so in this problem, what is L? What's L?
9.
9. Does it have to be 9?
No.
No, it can be 9 in this case. We're just going to use it. W in this case. Yes, 4. So what you're going to do here is you're going to do 9 plus 4, order of operations, right? Order of operations has infiltrated geometry because order of operations is what we use in math. So what's 9 plus 4? 9 plus 4? 13. What's 13 times 2? 26. Now, I need Swivl to follow me right now. and for you guys to pay attention because I'm going to grade it based on the next point I'm going to make. Is my answer 26?
No.
Callie, what do you think?
No.
No, wait. Oh, did I add? No, wait. 13, yep. 2, 26. Wait, what's wrong, Callie?
I have to add inches.
Oh, you mean right here? Units! In fact, mark my words, Swivl. Mark my words, class. If you don't put the correct units, you know what this answer is?
Wrong.
It's wrong. I'm sorry. If you put feet, 26 inches would be this, roughly. 26 feet would be from here to the back of the room plus some. So, the distance around that rectangle is 26 inches. Okay, all right, get that. Oh, I meant 26 miles. There's no biggie. There's a huge difference. Oh, no. I meant 26 teddygrams.
What?
I just heard.
That sounds
What
like
if Teddy Grams are close to an inch?
What if it's
All right, anyway, the units matter. When you're talking about perimeter, you must put units. You know back here, you know what you're going to put? Use units. And I want you to circle that and put a little asterisk because you will use units. If you don't use units, I'm sorry, it's wrong. And everyone now has heard it many times. If you're not sure, you can ask a friend after class. 26 inches. Yes, ma'am? You can put P equals, and actually, Elizabeth, that's great if you do. In this case, I'm going to be okay with just 26 inches. But yeah, that's good. Good thought. Yes, ma'am?
I thought you put the 2 over the inches. Or is that for something else?
Yes, that's actually for area, which we're going to talk about next. Okay, example 1B. So I'm looking at B now. And B gives me, what's M stand for? Anyone know what M stands for? Meters. Can you guys give me the distance of a meter roughly with your hands? You can. Okay, you're like, I don't know what a meter is. It's a little bit more than a yard. So if you're thinking of 3 feet, a little bit more than that, 39 inches is going to be a meter. So this is about a meter right here. Okay? If you know yards in football, you know a meter is just a little bit bigger than that. So this is 8 meters, 8 of these all the way across and 8 of them down. What is the length?
64.
I think I know your answer, but what's the length? What's the length of this square?
I think, 32?
You guys are thinking I'm asking for perimeter. I'm asking for length. Yes, ma'am. 8. 8 what?
Oh,
8 meters. The length is 8. Wait, is it this one or that one? Either one. Now let me help you out right now. Can the length and the width be the same? Yes. So if you have a problem where the length and the width are the same, that's okay. It happens. So you can call either one of these. I'll call this one the length, and I'll call this one the width. Okay. And this one's nice because is there a shortcut for figuring out the perimeter or the distance around this shape? What do you guys think the distance around this shape would be? How would you find it, Josie?
You just do 8 times 4.
Okay, I'm going to do 4 times 8. What does that give me? Since you guys know your multiplication facts, it should be a quick 32 meters. Okay, it has to be 32 meters.
I have a question.
Yes, sir.
What would be 4 times 8?
Good question. We did 4 times 8, and I'm thinking, okay, I kind of don't see that. Let's look at the other formula. Wouldn't it be 2 times the length plus the width? Remember, that's the old formula. And so what is 8 plus 8? And then what is 2 times 16? It's still 32, in this case, meters. So why did we pick 4? How many sides does this square have? 4, and they all have the same length or the same distance. So 8 times 1, 2, 3, 4, 32 meters. 32 meters is about how many yards? 35. I like that you're thinking. You can just think 32. Just think 32. Pretty close. But yeah, it would be over it. Very good. All right. Did I have my units?
Yes.
Did I put the correct distance around that shape?
Yes.
Combined together gives me a correct answer. All right. I want to see if you guys are really getting this. So please, on page 142, I want you to find the perimeter of number 5. No, you don't have to draw. You do not have to draw these. You just have to figure them out. I want units.
Oh, that's like units.
So 5. Find the perimeter of that figure.
Wait, what?
Find number 5.
Okay.
What about they don't give you any
If they don't, then you put the word units. Very good. Yeah, if they didn't put any units, they put meters, inches, feet, anything, you have to write out the word units because it's still a geometrical term. Ma'am, you have the answer? Okay, just a moment. Okay, JB, what was the length of that figure? He says 3. What's the width?
4.
Oh, wait. 3 is smaller than 4. Doesn't matter. Okay. So what's 3 plus 4? 7. 7 times 2? 14 centimeters. What's a centimeter, by the way? Can you guys show me with your hands? What's a centimeter? Or you get a centimeter would be about this. It's very small. Yeah, that's about a centimeter.
That's how big my brain is.
So a centimeter, or a distance of 14 centimeters, I'm going to approximate is like that, at the most. Maybe it's like that. 14 centimeters, very small. Okay. How many of you think you get perimeter and length and width? You really get it? Good. Look at number 8. Find the missing dimension of each rectangle. Do they want you to give them the perimeter? Why not? That's what we've been doing. They already gave you the perimeter. It's 32 inches. So what do they want you to get in number 8? They want you to get what's the width. You see W? You got to find out what W is. Oh my. What are we? Yeah, I would not trust it. Just like I would work it out myself because I'm guessing if they wrote in the book, they're probably not very good at following instructions.
But it's not either.
This is what you do, guys. Remember our formula? Do you remember this? Okay, what's the perimeter in that problem? 33? 32. So I already know what the perimeter is, 32. What's the length? Or did they give me the length? What's the length?
12 inches.
12. Did they give me the width? I have this problem right here. I have everything but W. Okay, guys, this is going to lead us to the next 2 lessons. This is what I need to do first. I want to find what W is, but I want to solve. So therefore, I want to solve for W. What would I have to do? This is a cool problem. It's good for us. It's preparing us for next 2 or 3 days. Jensen.
You have to add the 12 inches to each other. Make it 24.
I think I can see what you're doing, but I want to do it mathematically. Like I want it to where everyone's like, oh, I get what you're doing. Can I help you out here? I know some of you might know. Can I do this for you guys? This is a 2-step equation. 2-step equation. We've been doing one step at a time. This is what I do. Look at W. What's happening to W? It's being added with 12 and multiplied by 2. So it's being added with 12 and then multiplied by 2. How am I going to undo that? I'm going to get rid of the multiplication of 2 by doing what? Dividing by 2. Watch what I'm doing here. I'm going to divide both sides by 2. Okay? So what's 32 divided by 2? 16. Now, you're looking at this, man, Mr. A, that's really complicated. What's this 2 over this 2 mean? 1. That's just 1. And then you're left with 12 plus W. Sorry about that. What do you do now to get W by itself? Okay, you subtract 12 from both sides. That's okay. You get 4 equals W. Is 4 my answer?
Yes.
No, 4 inches.
I'm just going to say no because normally.
4 inches is my answer. 4 inches. Mm-hmm.
Do we have to show it like that?
Not yet. Soon you will. Yes, I know. Soon you will. Yes. Okay, yeah, go ahead.
Wouldn't it be W equals 4?
Yeah, you can say, and that was the question. I think Elizabeth said W equals 4 inches. You can do that. Yep. I want that 4 and that inches combined together. That's what I'm grading. Mm-hmm.
I thought it would be like 32 divided by 12 equals W.
So 32 divided by 12 would be a little less than 3. And so you're going to get 3. And then this is what I do. Like, okay, let's just say it was 3. But would 3 fit in this equation here? So what was the length in that problem again? 12? And then we say 3. What's 12 plus 3? 15 times 2 is 30. So you wouldn't get the 32. You'd be off of it. So yeah, you got to check it out. Okay, any questions on perimeter? You guys get perimeter? Okay, good. What's the second part of this lesson, you think? Area of a rectangle. Area of a rectangle. Okay, so that's our second part. And if you're in your book on page 140, we're going to look at that little green box again. Who can read that box where it says in words, in symbols? John, in words, please.
If a rectangle has a length of L units and a width of W units, then the area is L times W squared units.
Okay, good. And then can you read the symbols as best you can?
Wait, should I say the thing?
No, you can read it like that. A equals
L times W.
Yep, that's it. Okay, so this is what you need. Capital A equals lowercase l next to the W. What does that 2 letters next to each other mean? Multiplication. So you know that's multiplying. Okay, area. What is area? Before we even get to the formula, I need to know what area is because it's not the same thing as a distance. So can you guys agree with me? From here to here, there's a certain distance?
Yeah.
Okay. But how do you use area? Because you don't say I'm that many square units away. That doesn't make sense. Let's go with Michael. Let's try it. Okay, that's how you find the area. But what is area? Like, what do we mean by length times width? Like, huh? Yep.
I mean, like, what's on the inside of something, like all of what's on the inside.
Okay, good. You're getting there. You're starting to get it. Yes, ma'am?
The number squared units needed to cover a surface enclosed by a, I don't know how to say that word, geometry figure.
Geometric?
Yeah.
Geometric figure. Okay. It's the amount of space inside a 2D figure. All right, ready, guys? Go ahead and draw me. I should do it up here. Draw me another rectangle on this paper here. Any rectangle will do. Just make sure it's a rectangle.
Can I draw my hairstyle rectangle again?
Oh my gosh.
Okay, I'm going to draw my rectangle and just to try to make it unique, I'll do that. Okay. Go ahead and label your length and width. And remember, you know what your length and width is. Okay, so I have my length and my width. And the easiest convention is longer side length, shorter side width. That's okay. All right, when I'm talking about area, I'm talking about how many square units will fit into this shape. So perimeter was the distance around a figure, okay? Distance around a rectangle. The area is dealing with the space inside that figure. So when I say I'm this many spaces away from my figure, or from that wall, no, we don't say that. We say I'm this many units away. A square unit would be this. So I want you to try to sketch this out if you can. I want you to draw me a square inch. What you're going to do is you're going to draw an inch by 1 inch by 1 inch square, as best you can. 1 inch by 1 inch square. So an inch length and inch width. and that's a square. Okay, so I'm going to label it 1 inch by 1 inch. Okay, that's a square inch. That is called a square inch. Why do you think it's called a square inch? Because it's a square with what distance for each side? 1 inch. Good. I want you to draw me, and this is going to be kind of tough. I think you guys can draw it. Well, no, don't draw this anymore. I'll draw it, because really, I'm going to have to use my whole board. Draw us, if you can, or at least to show yourself, a square foot. So it's 1 foot by 1 foot. Don't do it. Don't draw it. Yeah, 1 foot. Don't do it. Yeah, you can't fit it. I mean, you can't. You literally can't fit it. All right. If you have a square that's 1 foot by 1 foot, what is that called? This is called a square foot. You guys get it? Square foot? Okay, and then my favorite one. I'm going to attempt to draw one. You stole my thunder. A square mile. So, okay. Oh, yeah, that's probably a bad idea. They just painted these rooms. Why would I do that? Okay, what would a square mile be? So this is up here, because I can't actually see it. What's a square mile? What's a square mile? I need to know what it is.
A mile by a mile.
It's a mile length and a mile width square. And that space is called a square mile. Now, what would you use to measure? What are you measuring when you use square miles? Anything? Is anything really that big?
Miles.
Building.
Light years.
Backyard.
Kilometer.
I would say like forest. You could say a forest is this many square miles. Can you say the surface of the water on our planet could be square miles? Square miles? Sorry? An island is this many square miles big? You could say that. Which one of these, square inch, square foot, or square mile, would you use to tell me how much surface each desk has? What would you say? And give me a reason, Marissa. What would you use? This one or this one? I hope not square mile, by the way.
Wait, could you use a square? I know you could fit squares inside of the desk, but the corners.
Oh, what a great question. Yeah, like I could fit them in most of it, but like here, wouldn't I have a partial square? So you can have areas that are 0.5, 0.9, 0.583. You can have a part of a square. So like if square feet would be one, I would say square feet's a good one. Would anyone use square inches?
Maybe if you felt finger.
Yeah, it's more accurate if you use square inches. So yeah, you can use that. You can do square centimeters. Yeah, square millimeter. You can do all those. Okay, let's look at example number 2. That's what I'm looking for. And I want us to write out this definition of area. Area is the space within a rectangle. And rectangles are two-dimensional. We're not talking about a rectangular prism, which is 3D. That's like a 3D box. No, we're talking about the surface. So the space within a rectangle. All right. So example number 2. Find the area of a rectangle with length 15 meters and a width of 8 meters. So what's the formula for area? A equals length times width. So what did they give me in that problem in example 2? They gave me the length, which is what? 15, and they give me the width, which is 8. So what do I do with 18? Or excuse me, what do I do with 15 and 8? Multiply them. And you're like, Mister, I can't do that in my head. That's okay. You do this. 15 times 8, and you should get 120. Very close. Square meters. Yeah, you can write S cubed. So I'll show you how you write it. There are many ways to write it, and I will see which one you guys are more comfortable with.
So if we pick one, but I prefer the M2, is it wrong?
I'm going to say this. Any one of these work. this one's the preferred method. It's shorter, right? But you remember, where does the exponent of 2 go? It goes after the m, or after the unit. It does not go right here. That is not where it goes. Not with that number. Do you understand that, guys? Mr. A, I accidentally did that on all my homework problems for area. It's wrong. You can't say 120 square meters. Or sorry, 120 squared meters. That means something else. So this is the method I want you guys to use, but you could use it this way as well. Does that make sense? Okay, let me ask you this. Is a meter and a square meter the same thing?
No.
Wait, they're both meters.
No.
Because a meter is straight. And
Okay, a meter is a distance, so 1 meter from here to there. What's a square meter?
An area.
It's an area. So it's like how many square meters are each one of these little tiles? We could say maybe a square meter, okay? But the distance is measured in meters. Okay, so with that, I'm going to make you write one more note. Remember up here? I want you to write square units. And then an asterisk, because that's what I want you to use. If you don't put the correct units, what happens on that problem? It's wrong. So I don't want to take it off of that.
give you a unit,
You write square units. And guys, this is stated square units, not units squared. It's square units. There's a big difference between those two. Can everyone say that? Square units?
Square units.
Do we ever say units squared?
Yes.
No, do not say that. Okay, one last problem before I let you go on your homework. I want you to do number 6. Find the area. Find the area of number 6. Page 142. Find the area of number 6. Say that again?
You want us to find the perimeter?
Not on this one yet. Okay, how many of you got 900?
I got 900 meters.
I got 9.
Okay, I need someone to give me the correct answer, and they got to be sure of it. Don't give me an incomplete answer. All right, here. Josie, what's your complete answer? 900 square meters is the answer. 900 square meters. If you just put 900, no way. I don't know what you're talking about. 900 what? If you just put 900 meters, that's a distance. So the distance around a shape is 900 meters is not the same thing as the correct answer, 900 square meters. You guys okay with those?
Yeah.
All right, your homework tonight. I'm going to pause this here.